Thank you, thank you. So it's actually not a problem, but a bunch of solutions. And the focus here is some experience that we had with some of our customers. But yeah, let's dive into. I'll try not to bore you too much with me. QA manager at ShapeBlue. I've been with CloudStack since 2017, part of PMC as well. All the jazz. And yeah, simply that, have to happily married and trying to be the best of me every day. So yeah, what is the background of this talk? So back last year, Abhishek did some improvements on performance side and the scalability side, and he did a talk talking about these improvements and saying what they're all about. But throughout the year, I actually had the chance to play with them and to see how they actually perform with some of our customers. And yeah, speaking of the user cases, so we did see that with one of our customers with running about 3,000 hosts plus, and another telco running about 200 hosts and looking to scale into the thousands, and a big tech company running about 20,000 hosts. So that was the highest tier of scalability that we've seen these improvements at. Just insert some caveats here before we start. So this is not like a fully fledged guide or instructions on how do you achieve certain performance. This is some patterns that we've seen in our customers, that we apply these kind of settings and changes, and we actually see some gain in the performance of their environment. So do not consider this as like a fully guide or like a certified, instruction, but just some takeaways that you can consume and probably apply at your instance as well, depending on the case that you're running. And another aspect, so nowadays we are quite used to scaling horizontally with hosts, but nowadays we do have hardware that gives you hosts with, let's say, hundreds of CPUs, so you can easily achieve that kind of resources with quite fewer hosts. But that's not the case that we are having with our experience, so just keep that in mind. Yeah, host is not the only aspect of scale, but this is the focus of these slides. And yeah, about the journey. So based on our experience, I kind of separated the journey in my own terms into three kind of areas. First, we have like a foundation base where you have up to, let's say, 200 hosts. And you have some specific challenges that you need to solve about this scale. We're going to talk about that. And then you have an optimization phase where you actually have the foundation, and then you start to see some changes in behavior and changes in performance. So you do need to worry about a little bit of different kind of problems that appear in your environment. And that's the next phase, when you scale about to the level of about 200 hosts, 2,000 hosts, sorry. And then when you up the game into like the thousands of hosts, for example, about 20K hosts, you start to see a whole lot of different set of issues that are appearing in the system. So you now have a completely different type of problems. And that's the third phase of improvements that we have identified. So let's dive into those. And yeah. So phase one, it's quite the basics, and let's quickly go through the challenges that we have in this phase. So in this phase, we basically need to set up the basics. You need to deploy your zone, you need to do the installation, you need to have your basics set up and figure out how many zones you're gonna have, how many pods and clusters and whatever. And you also need to pick your storage solution. So again, nothing really special here to do. So you need to, you can basically have to choose that. You need to think about hardware. You need to pick your hosts and your network devices, and you need to test that out. And you need to think about how you distribute your resources, like what type of offering you're gonna give to customers, and implement that. So let's talk about more about these. So you do need to set up the management server and database. You feel free to do that on the same machine. And as I mentioned here, you actually need to go with stock. And excuse my Italian, but you do actually need to do nothing here. Niente, I believe it is. So yeah, go with stock installation. Don't worry too much about it, and go on. So about networking it's always been a bit tricky depending on your business proposition, but we kind of suggest that you go with the usual community recommended with advanced networking model. Feel free to define your traffic isolation per each physical network for guest management, public, and storage, and you should be good to go. As far as storage, consider NFS. You don't really need anything complicated here. Yeah, you can play with the sizing of the packages, so you can reduce the ping pong and time to deliver, and yeah, nothing really special to do here. You do need to set up resource monitoring. And I would suggest go with the classics, use Prometheus and Grafana. We do have exporters for the management node. You can use the node exporter for the server itself, which will give you a good understanding of the CPU and memory that you're using and disk space. There's the MySQL exporter as well. You can monitor connections and queries per second, and also the JVM exporter, which you can actually track the management service itself. You do need to set up resource monitoring on the hypervisor and user instances layer. And I would suggest you can utilize the CloudStack native metrics view. You can have all the metrics for hosts and user instances feed it back to you with the CloudStack UI, or you can also utilize Prometheus exporter for that as well, if you will, to integrate it back to your system. And then you can also take advantage of the CloudStack alerts and events that you can configure to basically monitor some capacity thresholds and be notified when things starts to get out of reach. So, summary of this phase one. As you probably noticed, you simply go with stock installation. There is nothing really interesting and nothing really like funky to do here, and actually no scalability improvements. So, with our expertise, with our experience and the things that we've seen, I think up to like 200 hosts, you don't really need to worry that much about scaling and system. Moving on to phase two, let's talk about the challenges. So you are now running a fairly large environment. We're talking about environment in the thousands of hosts. So you do need to do some architectural changes to your environment and the way that you actually set up your cloud stack. Also, you are running some fairly big database, so you do need to worry about, you do need to do some optimizations with that database so that it can handle such load that this stage is having on the database. And you do need to do some network and storage optimizations simply because you're growing and now you're like in the thousands of hosts. So we're going to touch on that as well. And now you are also dealing with tons of data. So you do need to have like purging and like a strategy for manage that large data. The architectural changes you do at this level, you are running thousands of hosts, so you absolutely do need to separate your management server and DB. It's kind of a must at this stage. It's a no-brainer. So, and actually the benefits of that is you can actually scale and improve consume your resources a lot more better with having those two servers running on a separate machines. And you also don't have the noisy neighbor problem. So you have all your resources simply devoted to that particular service that you're running. As far as network and storage, networking bit is always depending on your offering and depending on the business case that you have. But at this stage, you do actually need to consider what type of solutions you need to have. But what we've seen with our customers is that simply going with the advanced networking model and VLAN trunking, it's running fine with the use case that they have. It basically enables you to have like 1,000 isolated networks, and you can do VPCs and all that jazz, and have a better mimicking of DC. Also, you can consider, again, depending on the business case that you have, you can consider SDN solutions or VXLAN and the BGP. Feel free to reach out to Guido about that. He will tell you more about it. But again, networking is a bit funky bit, so not going to touch a lot of that. So you need to do your own math there. As far as storage, at this stage, you can also consider some object storage type. And feel free to add that capacity dynamically to your clusters. Meaning, whenever a storage pool gets exhausted, simply add another pool to the same level and expand on that. You should absolutely be using cluster-wide pools. It's far more easier to manage, far more easier to scale, and try to avoid the zone-level storage. And of course, introduce storage stack at offering level to have better distribution, and think about over-provisioning if you do want to utilize the maximum of that storage. As far as performance, at this stage for the NFS, you can consider version 4 for better connectivity, and you can limit the concurrent snapshots per pool to 5, so you can avoid the concurrency issues. And yeah, and the last bit here is a thing that we did actually last year. It's the now you can actually select the workers that would reconnect the storage pool, and this is dramatically yielding some good performance because whenever there is like a network glitch or something, everything tries to connect back, and it really matters how fast it can connect. And we identified that this kind of magic number of 4 is kind of good, having good results based on our testing. You can actually see that the moment you introduce like multi-threaded connection managing, you dramatically reduce the number to connect, but then you kind of flat out. So it's really about 4. We think it's a good way to go here. And DB optimization. So now you kind of run in thousands of hosts environment, and DB is getting large, and there's like a lot of traffic to it. And on our experience, actually MySQL has been quite heavily tested in the community, and it's actually been proven to be battle ready, and it's not really a problem. It can easily handle like 50,000 queries per second. What's the actual problem is actually how you use the MySQL server. And we do, with CloudStack, there are some notorious slow queries and that keep dragging us down. And with time, more and more data gets accumulated in the system, and when you try to move this data and delete it and basically work with it, it gets fragmented on the physical layer of storage. So that's also affecting the performance, thinking about scale here. And yeah, basically to reduce that, we play with these MySQL settings. We increase the pool and the memory pool, and we also increase the log file size to reduce the slow queries. And also with that, we add indexing to large tables like VM instance and stuff. And that also dramatically reduces the fragmentation issues, which is also yielding some good results. Yeah, analyze optimize table also is helping with defragmentation. And yeah, at this stage, as mentioned, you do have large data to deal with, so you do need to implement the purging strategy. You can schedule that. There's a whole bunch of settings here to have an automatic schedule. I'm not going to go through that, but you can work this out. I guess it's you set your interval, you set how much you want to keep, and you set what you want to keep, what type of resources. And you should also consider that to reduce basically the burden. Also, of course, you can do on-demand purging with APIs. You can remove the resources like virtual machines and etc. And also you can remove storage with time. It's been proven to be a heavy load on the DB. As a summary of phase 2, now your system is growing larger, and you kind of start to experience some issues that start to matter in the process, like some performance issues. And you do need to pay attention to that. You do need to introduce the changes to the architecture and to the way you deploy your CloudStack. You do need to separate it. You do need to optimize your storage and solution. And you do need to optimize the DB as well. Most importantly, benchmark, apply changes, benchmark again, and compare and evaluate yourself what works for you and for your environment. That's the best advice I can give you based on our experience. And yeah, the third phase that we run into, and let's talk about the challenges there. So now you are running an environment with tens of thousands of hosts, let's say 20,000 hosts. This creates a lot of traffic and a lot of querying around resources. And generally around the database and the general pooling, you do have some challenges there, mainly around managing this type of traffic. Also, with this kind of large environment, you do also have start to appearing some concurrency issues, like some APIs start to run over on top of other APIs, and some deadlocks and some other such issues start appearing. And you do also need to focus on that. And you are now running thousands of hosts. So there's the agent issue there, because all these like 20K hosts want to connect just to a few management servers, and you do need to load, distribute this type of traffic. And on the lower level, in the management service itself and the Java process, we did start to see some hiccups with the garbage collection, which actually stalls the API performance. And we did some changes there, which actually yielded some good performance in that service itself. So let's see more details about that. Yeah. So DB pooling and concurrency. Yeah, as I mentioned, you now have a database that is handling quite a lot of connections. And the database needs to be actively managing these connections, like what to drop, what to keep, and what to respect. And we noticed that the default pooling library is not really performing at scale. And we discovered this Hikari CP, which is especially designed for managing large connection pools. And with it, we did see some good increasement in that direction. So I do recommend, it's a simple setting in the DB properties. Simply change that, and it should be applied, and you should see that. Also, as far as the concurrency, we introduced cache at the DB layer. So we played with these MySQL settings. Also, we enabled the cache and the thread concurrency at the DB server. And this is depending, of course, on your hardware. But with the instances that we're running, we identified that these are quite okay. So, and as far as the concurrency, you can multiply by 2 the cores that you have. So if you're running like 32 core, feel free to use 64, and that should boost and utilize the multi-threaded concurrency on the DB layer. And some general pooling in CloudStack. So now CloudStack has a lot of resources to deal with, like thousands of hosts, thousands of storage pools. And this means that it constantly needs to know what resources do I have, how many storage is left, how many RAM is left there on the host. And this is constant pooling of resources. That creates a lot of management traffic, and it does become a bottleneck, and it kind of does add up to the network, and it stalls it a little bit. So we identified these settings in CloudStack, and you can, I'll share the slides later, you can play with those and actually tune to your best, to match your environment, and to basically regulate how often does the ping interval goes, and how often it calculates the capacity, and how often does it syncs the state of resources, so you can actually optimize the traffic going on the management layer. API caching has been always an idea, but we kind of worked in that in the last year. So what's the actual issue? Some APIs are being proven to be a bit slow, and due to the reason for that is that they actually do some repetitive actions, like they go to management server and ask for permissions, and then they execute something. They ask for another permission for another operation, and then they, in the meantime, they multiply query the configs for the global settings for a particular config, and back, and that is kind of repetitive queries for the same kind of, not the same, but different kind of configs that are needed through an API. If you think about deploy virtual machine API, that is one of the most complicated APIs in CloudStack, and it does for each and every resource that it touches, like the CPU, the memory, it goes and asks for permissions, goes and asks for specific configs, and that is kind of repetitive. And to reduce this back and forward conversation, basically, we added a in-memory caching that is basically caching the DB settings. It's caching also the permissions, and it actually improves the API responses. And based on our results, we achieve like 30% config key retrieval improvement in that. And with the deploy instance API, we actually had some significant improvements. I think about 20% improvements in the actual API performance. And now this looks like 50%, but it's it's actually 20. So yeah, this caching framework really helps in the performance of the APIs. It's one of the changes that we did last year, and it's quite recent. So it's still kind of new in the space. Moving on to the next challenge. So you do have thousands of hosts now. This is a lot of agent communication, trying to connect to the management servers and talk. The obvious solution here is introduce load balancing, this native feature of CloudStack. So you can have your algorithm selected for load balancing. I would suggest round robin. This is simply having a distributed schedule of host connection, and with this host setting you define your list, and that list gets propagated to all the agents in a sort of round robin way. And some communication improvements. So thinking about scale, now you have thousands of hosts, and if you imagine some network glitch happening or something, a switch goes down and all these hosts are hanging and they need to connect back. So this is like enormous queue for the network and the management layer. And dealing with that, we were encouraged to try to improve that and try to reduce such downtimes as much as possible. So we did some improvements in the way a TLS communication has been established and handled. And also, we did introduce some concurrency in that connection process. So, meaning a one server can have manage multiple connections at a time, which actually yields some drastic results. And before these changes that we did in 420, so after these changes that we did, we actually see more than 50% increase in managing this and establishing this connection. And if you think, I mean, if you simply look at it, doesn't really look that much from like 0.3 of a second to going to 0.1 of a second. But if you put that in the scale, like in the thousands of hosts, that is actually a lot, because you are reducing this enormous queue that is happening by half and more, which is actually a drastic change. And finally, about the JVM garbage collection, we did identify the management servers when it's using that many objects and working on that scale. The garbage collection itself, the default one, it starts to have some hiccups. And it starts to stall the process, and it starts to degrade the performance of the process itself, the service. So we explored in that direction and figured out that this parallel GC is having those issues. So we explored this other algorithm called G1GC, and here's the settings that you need to apply to enable it, basically. And with this algorithm, we've managed actually to receive some better performance. I'm nearly done. So yeah, better latency and better handling upon burst loads with this type of algorithm. And some final thoughts for phase one. When you're dealing with let's say 200 hosts, you don't really need to do much of scaling settings and optimizations at your environment. When you scale that to 1,000 hosts or even more, you do need to think about individual performance of components, and you do need to optimize that so you have a complete solution that you can scale into the thousands of hosts. And when you get there, you actually need to worry about some different vector of problems, like managing the connection pools and managing the multi-thread and the API concurrency. So that's kind of the gist of it. So yeah, and once again, these are not rules. This is not a full guide. This is something that we just observed with our customers, and we've seen that this kind of yielded some gains. And yeah, consider this as a starting point of your scaling journey, not a final solution.
Thank you, Bobby. Yes, round of applause.